Hey everyone, welcome back. Today we are diving deep into building modern reactive systems right inside Azure. We're going to explore how a serverless, event-driven approach can really unlock your applications, making them faster, way more scalable, and a whole lot more flexible. Let's jump right in.
So, let's start with a question that, I think many of us have had to ask ourselves. Is my architecture actually holding me back? You know the feeling. With those traditional monolithic apps, everything can feel like a massive traffic jam. Every tiny change means a huge deployment, scaling one little piece means you have to scale the whole thing, and a single bug can bring the entire system crashing down. It's the classic bottleneck.
But the good news is, there is a way out of this maze. We can absolutely escape these old, rigid structures. And we do it by rethinking the very way our services talk to each other. And that's where this more modern, more flexible way of building things comes in, event-driven design.
So what is it, really?
Well, think of an event-driven architecture like a digital central nervous system. Instead of one big central brain telling everything what to do, you have different parts of the system that just react to things as they happen. An event is really just a simple fact, a record that something happened, like an order was placed or a payment was processed. Services can subscribe to the events they care about and completely ignore the rest. And the real magic here, they're completely decoupled from each other. Okay, so to build this kind of system in Azure, you're going to need the right set of tools. Let's open up the toolbox and look at the core serverless services that make all of this possible. These are the absolute essentials for your architectural toolkit. Now, what I love about this is how clear it makes things. For broadcasting one event to tons of different listeners, Event Grid is your go-to. It's like a news broadcast service. But for those critical, can't-fail transactions where you need guaranteed in-order delivery, that's when you bring in Azure Service Bus. Think of it like certified mail. And for just simple, massive scale queuing, storage queues are like your standard mailbox. A really common mistake is to over-engineer, right? Using the power of Service Bus for a simple notification that Event Grid could handle way more efficiently. Choosing the right tool for the right job is absolutely crucial. So, if those messaging services are the nervous system, then Azure Functions, well, they're the muscles. This is your serverless compute, the code that actually gets the work done. It's the glue that sits there, listens for an event, and then bam, it executes your business logic and response, all without you ever having to provision or manage a single server. All right, theory is great, but let's make this real. We're going to walk through a super common scenario, processing a new customer order. We'll see exactly how all these Azure services play together to create a really seamless, reactive workflow. And it all starts right here. A customer on your website clicks Buy. That one simple action fires off a web request to an endpoint, which immediately triggers our first Azure function. And this function has one job and one job only, to kick off the process. Now, listen closely, because this is where the magic really starts to happen. After validating the request, the function doesn't call the payment service or the shipping service directly. Nope. Instead, it just announces a fact. It publishes an order-created event to Azure Event Grid. It just shouts into the void, hey, an order was created. And then, its job is done. And this is just a beautiful illustration of that decoupling power. Over here, you have the shipping service. Over there, you have the inventory system. They're both just listening for that order-created event. When they hear it, they each kick off their own totally independent processes. Shipping starts creating a label, while inventory updates the stock count. And here's the key. They don't know or even care that the other one exists. They only care about the event itself. Of course, in the real world, things break. What happens if a database is down for a minute? Well, Azure services have automatic retries built right in. And what about a message that's just bad? It's malformed, and it's always going to fail. To stop it from gumming up the works, it gets moved to what's called a poison message queue for someone to look at later. And distributed tracing? This is amazing. Think of it like putting a GPS tracker on your event. It gives you a complete map of its journey across every single service, so you can pinpoint exactly where things got held up. So, what we've just built isn't just a one-off trick. It's actually a powerful, repeatable strategy, so let's zoom out of it and look at 4 common pro-level patterns that you'll see all the time in event-driven design. First up is the fan-out pattern, which is exactly what we just saw in our order example. This is when one single event needs to kick off many different things all at the same time, in parallel. Our order-created event fanning out to both shipping and inventory is the textbook example of this. And it's what Azure Event Grid was literally designed to do. But what if the steps have to happen in a specific order? Well, that's where workflow orchestration comes in.
This pattern is for those more complex, stateful processes. Think about workflows that need to have a memory. They have to know what happened in step 1 before they can do step 2. A multi-stage approval process or a new user onboarding that might take days to complete, those are perfect use cases. This next one is all about the user experience. If a user's action kicks off a really slow task, like processing a huge video file or generating a complex report, you do not want to make them sit there staring at a spinner. Instead, you accept the request instantly, give them a thumbs up, and then offload all that heavy lifting to a background job that gets triggered by an event. Your app stays snappy and responsive. And finally, in this world of microservices, how on earth do you keep everything in sync? The answer is integration events. So when a user's profile gets updated in the user service, that service just broadcasts a user updated event. Other services, like orders or shipping, can listen for that event and update their own local copies of that user's info. It's how you keep data consistent across a whole distributed system without creating a tangled mess of direct API calls. So, if there's one thing to take away, it's this. Moving to an event-driven mindset isn't just a technical choice, it's a strategic one. The real goal here is to build systems that can handle failure, that can scale to meet any demand, and that can evolve easily over time. And having loosely coupled services that communicate through events, that is the key to it all. And that really brings us to the end, and it leaves us with a question to take back to our own projects. Where is that tightly coupled process that's causing a bottleneck right now? What's the very first event that you could set free in your own system to make it just a little more resilient, a little more flexible? Thanks so much for tuning in.